Alright, so here we're working on puzzle 4 from the cubic family. And so we're told that f of x is equal to ax all cubed. That's one clue, and our other clue is the transformations here. It's a reflection over the y-axis. And so if it's a reflection over the y-axis, remember to think about this, it's over, this part would be reflected over here. The x value is changing, and the x value goes from positive to negative, and so this is negative x cubed is our function here. And we have to be able to read the transformations and make sense of what's going on here. So it's reflected over there we go. Okay, I also know that algebraically it's the same as negative x cubed, where in essence it's in that. But it was asked for as such, and so I'm going to write it like this. All right, so now it wants me to sketch it with at least 3 points. So I'm going to go here. I'm going to make myself a table. We have x and f of x. And I'm going to start at 0, 0, and I'll go negative 1 and positive 1. 0, 0, because I know I plug in 0. If I plug negative 1 into here, negative 1 with a negative becomes positive. To the power of 3 is 1, so that becomes a 1. If I take 1, put in there, I get 1 times a negative. Makes negative 1 to the power of 3, makes it a negative. And so I can see it's going to go this way. The other thing I could have considered is if I would have thought about this graph here is just plain x cubed. And so I know it's been reflected over the y-axis, so therefore it's going to be this value reflects, and so on. And so let me just, there is my graph as such. It says label 3 points. So 0, 0, 1, negative 1, and negative 1, 1. I do know if I would do negative 2, that will give me a positive 8, and a positive 2 will give me a negative 8. All right, and so my pivot point is 0, 0, which is also my x-intercept and my y-intercept, all the same value. My domain is all real numbers, as is my range. If I want to find the inverse, well, I switch my x and y, so x is equal to minus y all cubed. I can also take off the parentheses and go minus y cubed, bring the negative over, so it's negative x is equal to y cubed, and then I could take the cubed root of x, negative y, which is the same as negative cube root x of y. And so this version or this version, they are both correct. And then to answer the question more perfectly, I do not leave it as y. I go back and I put it as it is stated. And next year, in 2 years' time, when you take your IB exam, you will have kept all your points and not lost any. And it is indeed a function. All right, so continuing on through the puzzle, this part's done. I will write down my function f of x is equal to negative x cubed so I can remember it. Well, if I'm going to do f at 2, well, I've already done f at 2. It's negative 8. F at 1, well, that's here. If I look here, there's only one value. It's already been done for me as well. X is equal to negative 1. And so function notation, use the clues and the puzzles available. You don't necessarily have to do computational work to do these a second time. And then finally it says simplify f of this and put it into this form here. So that means I'm going to go 1/2. And then into f, I'm going to go negative 2p. So into here, it's going to be, here's my negative, and then the negative 2p is in my x value, cubed plus 1. Now it tells me what form I want, so I have to keep simplifying. So 1/2 inside the parenthesis gives me a positive 2p cubed plus 1 is 1/2. Now this cube talks to the 2 and the p, so it's going to be 2 cubed times p cubed plus 1. Well, this is 1/2 times 8 times p cubed plus 1. Well, and that is 4 p cubed plus 1. And I know I'm done is if this looks like that, which it does. Continuing along through here, oh, it says sketch the tangent line on your graph f prime at -1. So this is a new idea here. For the tangent line, what that means, a tangent line, so the new idea, I'm gonna make some kind of a graph here, and let's look at this point here, and let's say this is 3, and so this is the coordinate point 3, f at 3, let's say. So if I want to find f prime at 3 is how we say it. That's saying find the slope of the tangent line. Well, a tangent line is a line that touches the graph only at one place. That's not a very good line. Let me try another line. If I come along here and it just goes and touches the graph slightly at a place like that, so that is a tangent line. Here would be another tangent line, and here would be another tangent line. This is not, because it goes through. You just want to try and kind of kiss the graph. This is not a very good tangent line there, and so on. So it just does it. And then you estimate the slope here. And if I look at this slope, I know it is a negative slope. And I'm only concerned if it's negative, positive, or 0 is all you have to do. So when I look at this graph here, and I want to estimate the tangent line f prime at 1, well, here is 1. And so I'm going to put a line here that just kind of bounces off, and I can clearly see that this is a negative slope, and that is all you have to do, say that it's negative. Using the function transformation, rewriting it, here's my graph here. Well, that's just going to be negative x, and that will be sufficient. If I check that with Desmos, if I call f of x equal to negative x to the power of 3, that's what I want to be. And if I make this negative, you can see that they are the same graph. And then finally, the last bit, we are going to evaluate this f of r of 2. Well, r is here, so that's going to be f of 2 times 2, which is f at 4. Plugging it into here, I get negative 4 to the power of 3, which is, oh, I have to use my calculator for that. Let's just say 4 to the power of 1 divided 3, 1.587, so negative 1.59 to 3 significant figures, and that is all we have to do.